So let's solve this problem. A person needs a lens of power minus 5.5 diopters for correcting his distant vision. For correcting his near vision, he needs a lens of power plus 1.5 diopter. What is the focal length of lens and required for correcting? So we have to find out. First case, it is distant vision. So distant vision, they have given the power. So power P, power of lens P is equal to minus 5.5 diopter. We have to find the focal length for correcting a distant vision. So we have to find out F. So the formula for P is equal to 1 by F in meter. So F is equal to 1 by P in meter. Substituting the values, F is equal to P, it is minus 5.5. So in order to remove the decimal point, we have to multiply with the 10 by numerator and with the numerator and also with the denominator. So minus 5.5 into 10, it is equal to 10 by minus 55. When we are cancelling, 2 5s are 10 minus 11. So we got F is equal to, so 2 divided by 11. 2 by minus 11 in meter. So meter, we are converting it into centimeter. So when we convert it into centimeter, we have to multiply 100. So 2 by 11 into 100. So 200 divided by minus 11. So let us do this side. 200 divided by 11. So we are taking two number. 1, 11 is 11. Remaining 9, bringing down the 0. 8, 11, 88. Remaining 2, we have to add 0 here. So we have to keep the decimal point here. So 1, 11, 11. Remaining 9. It just goes like that. So F is equal to, minus 18.1 centimeter. So focal length value we got negative. So it is negative. So what is the corrective lens we have to use is concave lens. So concave lens should be used to, correct distant vision. So we got negative value. So concave lens should be used. The lens with focal length of minus 18.1 centimeter should be used to correct distant vision. Second case, it is near vision. So near vision, they have given a power plus 1.5 diopter. P is equal to plus 1.5 diopter. So substituting value, so we can find out F is equal to 1 by P in meter. Substituting the value, F is equal to 1 by 1.5. So in order to remove the decimal point, 10 divided by 10 is equal to 10 by 15 meter. So when we convert the meter into centimeter, again we have to multiply 10 divided by 15 into 100. So we can cancel 2, 2 5s are 10, 3 5s are 15. So 200 divided by 3. So F is equal to 200 divided by 3. We can divide by writing 200 divided by 3. So 20 we are taking, 6 3s are 18. Remaining 2, bringing down the 0, 6 3s are 18. Remaining 2, if we want to add 0, we have to keep decimal point. So 6 threes are 18. So it just goes like that. So F is equal to plus 66.6 centimeter. This is also centimeter. So unit you should not forget. So we got the plus value. Focal length it is plus 66.6 centimeter. So in order to correct the near vision, we have to use the convex lens. Convex lens which has focal length of plus 66.6 centimeter. So convex lens is the corrective lens. Let's solve this problem. The far point of myopic person is 80 centimeter in front of the eye. What is the nature and power of the lens required to correct the problem? So here, by using a given value, we can draw a ray diagram. To understand, we are drawing a ray diagram. So in the near point, myopic person. So this is a myopic person. So they can see nearby objects, that is object at 25 centimeter they are able to see. So this is the near point. Far point is infinite. Far point for normal person. Far point it is infinite, but myopic person they have given it is 80 centimeter. So far point is shifted to 80 centimeter. So far point is shifted as it is in front of the lens, it is minus. So now when the object is in the infinite, the person should be able to see. Okay, so in order to correct that, we are going to find the corrective lens. What is the power of the corrective lens? So infinite, it will be object. So the object is in the infinite place. The image, it should fall on 80 centimeter. So then only the person is able to see the object. So V is equal to minus 80 centimeters. So by using these values, we can find out what is F. So using a lens formula, 1 by F is equal to 1 by V minus 1 by U. Substituting the values, 1 by F is equal to V minus 80 centimeter minus 1 by U infinite. So 1 divided by infinite, it will become 0. So minus 80 centimeter minus 0. So 1 by F is equal to 1 by F is equal to 1 by minus 18 centimeter. F is equal to, 80 minus 80. So F is equal to minus 80 centimeter. So we found out the value of F. We have to find out the power of lens. So P is equal to 1 by F in meter. Substituting the value 1 by minus 80 centimeter. But the centimeter, we have to convert it into meter. For doing that, we have to multiply 100. Minus 80 centimeter. When we multiply 100, it will become meter. So when you are cancelling, 4 twos are 8, 5 twos are 10. So P is equal to minus 5 by 4. So when you are dividing this 5 divided by 4, so 5, 4, even if it is small concept, you have to write and do it. So 1, 4 is 4, remaining 1. If you want to add 0, decimal point. So 10, 2 fours are 8. remaining 2. If you add 0, 5 fours are 20. So the P is equal to minus 1.25. P unit is diopter. So the value is negative. The value is negative. So remedial corrective lens is concave lens. The remedial lens is the concave lens with the power of minus 1.25 diopter. A person with a myopic eye cannot see the object beyond 1.2 meter distinctly. So what should be the type of corrective lens used to restore the proper vision? So for easy understanding, we have to draw the ray diagram. So this is eye. We are drawing a ray diagram. For myopic person, they are able to see the nearby object. So nearby object, it is 25 centimeter. They are able to see, and they cannot see object beyond 1.2 meter. So for normal person, the infinite it will be 4 point. For this myopic person, the 4 point is shifted to 1.2 meter. So 4 point is shifted. So the person can see things only this places. So this places can see beyond this, they cannot see. Cannot see. So if the object is at infinite, that is u is equal to infinite, the image it should fall on this limit. So that is image should fall on 1.2 meter. So it is in front of the lens. So minus 1.2 meter. So by using this, we have to find out what will be the focal length. By using a lens formula, it is 1 by f is equal to 1 by v minus 1 by u. By substituting the values, 1 by minus 1.2 meter minus 1 by infinite, it is 1 by f is equal to 1 divided by infinite, it will become 0. So 1 by minus 1.2 meter. So f is equal to minus 1.2 meter. So already it is in meter. So we can use this directly to find out what is P. So P is equal to 1 by f in meter. That is 1 by minus 1.2. If you want to remove a decimal point, you are multiplying with 10. So this is equal to 10 by 12. So P is equal to 10 by 12. It is minus. So we are calculating this 10 divided by 12. It is smaller number. So we have to add decimal point and add 0. So 8 12s are 96. Remaining 4. 0 we can add. 3 12s are 36. 4. It goes just like that. So P is equal to minus 0.83 diopter. So the value is minus value. So the corrective lens is concave lens. Concave lens, focal length of minus 1.2 meter and power of lens is minus 0.83 diopter. So concave lens of minus 8, concave lens of minus 0.83 diopter can be used to correct for proper vision. Let's solve this problem. Make a diagram to show how hypermetropia is corrected. The near point of hypermetropic eye is 1 meter. What is the power of lens required to correct this object? Assume that the near point of the normal eye is 25 centimeters. So we have to see it is the hypermetropia is given. So we can draw the ray diagram For easy understanding, we are drawing a ray diagram. Hypermetropia means they are able to see faraway objects. Faraway objects. So faraway object, it is far point, it is infinite. Far point, it is infinite. Near point for the normal person, it is 25 centimeter. But for this hypermetropia person, the near point is shifted to 1 meter. So the near point is shifted to 1 meter. So 1 meter is near point. Near point is shifted. Near point is shifted. So this place, they cannot see the objects. So object in this place, they cannot see. So this place, they can see. Beyond that, they can see. Can see. So if the object is at 25 centimeter, that is u is equal to 25, it is minus 25. The image, it should fall here, 1 meter, this place it has to fall. Then only the person can able to see the object. So the 1 meter, it will be V. So V is equal to minus 1 meter. So by using these values, we can find out the F and P. So by using a lens formula, 1 by F is equal to 1 by V minus 1 by U. So substituting the value, 1 by F is equal to 1 by minus 1 M minus 1 by minus 25 centimeter is equal to 1 by meter. We are converting it to 100. So minus 100 centimeter. Minus into minus plus. So 1 by 25. So what is the LCM? LCM for 125, it is 100. So we are taking 100 in the denominator, minus 1 plus 425s are 100. So 1 by F is equal to greater number symbol, 4 minus 1, 3. So 3 plus 3 by 100. So F is equal to 100 by 3. 100 by 3 centimeter. So centimeter, we are converting it into meter. So F is equal to 100 divided by 3 whole divided by 100. For converting it into centimeter into meter, we have to divide by 100. So instead, we can write 100 divided by 3. The inverse of this can be multiplied. So 1 by 100. We are multiplying 1 by 100. So when we cancel it, F is equal to 1 by 3 meter. So by substituting this values, the F value, we are finding out the power of lens. P is equal to 1 by F in meter. So P is equal to 1 by F is 1 by 3 meter. So 1 by 3 already is in meter. So we can substitute directly. So 1 into reciprocal. Reciprocal of 1 by 3, it is 3 by 1. So P is equal to 3. So plus 3 diopter. So we have positive value. We have positive value. So we have to use the convex lens. Convex lens to correct the hypermetropic person. So convex lens of plus 3 diopter to be used to correct the hypermetropia person.